Hey, so in this section, we are going to learn some more derivative formulas. In 2.3, we learned some derivative formulas. Today, we are going to learn more derivative formulas. But before even we start, we have this very important limit, which we need to remember. I'm not going to go into much theoretical proof of this, but I would like to give you a simple proof. So I'm trying to say that limit x approaches to 0, sine of x by x is equal to 1. Okay. I don't want to give you too difficult. There's a theoretical proof, but we don't really need to do that much. But I do want you to understand where it's coming from in a general example. Let's see if I can try to put 0 in here. It will be sine of 0 by 0. So that is 0 by 0 form. So it's kind of an example of an indeterminate form, which we learned in L'Hopital's rule. So I can apply L'Hopital's rule to it, and this can look like limit x approaches to 0. Derivative of sine x is cosine x by derivative of x is 1. So basically that is just limit x approaches to 0 cosine x. And now you can simply put 0 in there, and that will be cosine 0. The answer is 1. So that's what we are saying here, that limit of sine x by x as x approaches 0 is 1. So this is an important limit. Write it in your formula sheet. That's how we're going to go with that. There is another limit which we're going to talk about. That is the limit of 1 minus cosine x by x as x approaches to 0. That limit is 0. Okay. So I have done a little bit work out here. You don't want to go into much detail of it. Let's try that one also in the indirect way. So let's look at this one. If I try to put 0 in here, 1 minus cosine 0 is 0 divided by 0. So this is an indeterminate form. So I can apply L'Hopital's rule to this also. What will we get? Limit x approaches to 0, derivative of 1 minus cosine x, derivative of 1 is 0, minus derivative of cosine is negative sine, so it will be positive sine x, by the derivative of x is 1. So that is limit x approaches to 0 sine x, and that should be simply sine of 0 because sine is a continuous function. The answer is 0. So to all that discussion, we are going to simply get two formulas. Limit x approaches to 0 as 1 minus cosine x by x should be 0. Add this to your formula list. Okay. Now, why am I talking about these? Because we use them. We're going to do two questions based on that. These are special kind of limits. The first one here is limit x approaches to 0 sine 3x by sine 7x. I want you guys to remind you that I just taught you a formula that limit of sine x by x as x approaches to 0 is 1, and limit 1 minus cosine x by x as x approaches to 0 is 0. We are going to use these, okay? So let's look at this one. Now, if I put 0 in here, 0 by 0, that's an indeterminate form. I can't do that. I mean, we can use L'Hopital's rule, but I want to show you using this method. Limit x approaches to 0. I'm going to write this one more time. I'm going to divide both of these terms here. I'm going to divide this by x and this by x also. I can, because this x and x will cancel each other. So really it's not making any difference. So I'm not really changing the question. Also, I am going to, because I need it to, if I want to make it look like this angle and x should be same. But here it's 3x and this is 3x only, right? So I need to make this 3x. But I can't just put 3. I need to multiply it by 3 here. That 3 will cancel. Okay. Similarly, it should be 7 here and 7 here. That will cancel here. So what we are saying that this limit can be written as 3 by 7, that's just a constant, sine 3x by 3x. Actually, we can even take this constant out of the limit. 3 by 7, limit x approaches 0 of that divided by limit x approaches 0 of sine 7x by 7x. So the top limit is equal to what? 1. This limit is equal to what? 1. Both of them are 1 using the formula which we just learned. So the answer is 3 by 7 times 1 by 1. The answer should be 3 by 7. Okay, let's look at part B. Here we have this limit x approaches to 0. Now this looks long. I'm going to separate it out. Let's see if you guys agree with it. So in the denominator there was x squared. Now it's x here and x here together. They make x squared. In the numerator it was sine 2x times. So because of the limit algebra, we can separate them out and then multiply. Now here in the first limit to evaluate it, I should have 2x in the denominator. So I can multiply by 2 and divide by 2 here. So now this part's limit is 1, right? Because of the formula. So we can say 2 times 1 times this part here approaches to 0. So the answer should be 2 times 1 times 0 is 0. This is a method of evaluating special limits. Here, let's take another example of this kind where we are going to use the rule. Let's write down the rule which we are going to use. Limit x approaches to 0, sine x by x is equal to 1. Remember this, okay? Let's work this out. I'm going to rewrite this. Limit x approaches to 0, sine 3x. In the denominator, you see x is in both of the terms. I can factor x out. This is going to be 5x squared minus 4. Okay. I'm going to write them separately. Sine 3x by x times limit x approaches to 0 of 1 by 5x squared minus 4. Now, to apply the rule, 3x should be in the denominator too, so I need to make this 3. But if I write 3 there, I need to multiply by 3 too. So this portion, as x approaches to 0, will approach to 1. So your answer should be 3 times 1 times, for evaluating this limit, you can simply put x equal to 0 in here. So that will be 5 times 0 minus 4. Basically 3 divided by negative 4. The answer is negative 3 by 4. Let's do one more example. One more time, the formula we are basing these special limits on are limit x approaches to 0, sine x by x should be equal to 1. Okay, I'm going to write this one more time. This is just in terms of theta. Can I write instead of tangent theta, it has sine theta by cosine theta? Step 1. So I'm just trying to take tangent theta as sine theta by tangent theta. Now in the next step, I'm going to, because I need somehow sine x by x format. So I'm going to divide everywhere, numerator and denominator, by theta. Okay, I can do that if I divide both places, theta just cancels out. The top limit, let's separate out the limits. Now, this portion can be written as, we can open this as theta by theta is 1 plus this by this is sine theta by theta times 1 by cosine theta. Okay. Now see, when theta approaches to 0, this limit should approach to 1. This thing should also approach to 1. What about cosine 0? Cosine 0 is just 1, right? So that should work out. 1 by 1 plus 1 times 1 by cosine 0. That's also just 1. So 1 by 1 plus 1. The answer is 1 by 2. So that's an interesting way of using this formula to evaluate this limit.